Ever get totally tripped up by the least common multiple? Yeah, you're definitely not alone. But underneath all that math jargon, the LCM is actually this incredibly logical, honestly really satisfying piece of mathematical machinery. So, in today's explainer, we're going to demystify the whole thing step by step. Let's dive right in. Okay, so here's our roadmap for today. We'll quickly look at what the LCM actually is, we'll factor two numbers, and then we're going to step it up to three numbers. After that, I'll show you a really handy trick for comparing the HCF and LCM, followed by a quick quiz to test your skills, and then a final lesson recap.
All right, Section 1. What exactly is the LCM?
So the least common multiple is pretty much exactly what it sounds like. It's the absolute smallest multiple that two or more different numbers share. You can kind of think of it as finding the earliest common ground between different paths. And the absolute most foolproof way to find it? Prime factorization. We essentially take numbers and break them down into their fundamental DNA, their prime numbers, just to see how they connect.
Moving on to Section 2. Let's try factoring two numbers.
Okay, let's break down 18 and 24. For 18, well, that's 2 times 9, which breaks down even further into 2 times 3 times 3. Simple enough, right? Now, for 24, that one breaks down into 2 times 2 times 2 times 3. Now, here is where the real magic happens. We don't just multiply everything blindly. First, we grab the exact overlap. As you can see, they share a 2 and a 3. But wait, we aren't done, because the LCM requires us to bring down all the remaining unshared factors from both sides as well. So, when we combine those common factors with the remaining ones, we get 2 times 2 times 2 times 3 times 3. And doing the math on that, that gives us 72. So 72 is literally the absolute smallest number that both 18 and 24 divide into perfectly. Pretty cool, right? Next up, Section 3, factoring three numbers. Okay, so we can actually handle three numbers super easily using a division table. We just line up our numbers, 9, 12, and 18, and start dividing by the smallest prime number, which is 2. Now, if a number doesn't divide evenly, like that 9 right there, it just drops straight down to the next row untouched. We keep dividing by 2, and then, when we can't anymore, we move up to 3, basically whittling the numbers down row by row. And the moment you hit all ones right across the bottom, boom, you're finished. Now you're just going to grab all those prime divisors we gathered over on the left side. So that's a 2, another 2, a 3, and a 3. Multiply them all together. Let's see, 2 times 2 is 4, times 3 is 12, times 3 is 36. And just like that, we found the least common multiple for three numbers, the whole shebang.
All right, Section 4. This is the HCF versus LCM trick.
It's incredibly easy to mix up the highest common factor with the LCM on a test. Believe me, it happens all the time. But the trick here is all about those leftover numbers. For the HCF, you're being exclusive. You use only the common factors. But for the LCM, you are inclusive. You use the common factors and you sweep up all those remaining factors. So, HCF is only, LCM is and remaining. Lock that in your brain right now.
Which brings us to Section 5. Quiz time.
Okay, here's your first challenge. Find the LCM of 4 and 6. Try to think about their prime factors, find the overlap, and then multiply by what's left. Go ahead and hit pause if you need a quick second to work it out.
All right, and the answer is 12. Let's just quickly mentally verify that together. So 4 is 2 times 2. 6 is 2 times 3. Their common factor is a single 2, right? And the remaining factors are a 2 and a 3. So the common 2 times the remaining 2 times the remaining 3 equals 12. Huge congratulations if you nailed that one. Moving on to the next question. This one's testing your conceptual memory from just a few minutes ago. True or false, the LCM calculation uses both the common factors and the remaining factors. Think back to that memory trick we just went over. It is absolutely true. Sweeping up those remaining unshared factors and throwing them into the final multiplication is exactly what makes the least common multiple different from the highest common factor. Great job. Okay, here is your final rapid-fire challenge. What is the LCM of 2 and 8? Now this one is slightly sneaky, but I bet you can figure it out. Take a second to picture the multiples. And the answer is 8 itself. Why? Well, because 2 goes perfectly into 8, so the absolute smallest multiple they both share is just the number 8. Fantastic work and tremendous effort during this interactive segment. By practicing actively like this, you are literally cementing these mathematical pathways right into your brain.
Finally, Section 6. Let's do a quick lesson recap. Just look at what we've covered today. We defined the LCM in plain English. We mastered the Prime Factorization Method, applied it to 2 numbers, scaled it all the way up to 3 using a division table, and we anchored down a foolproof trick to tell HCF and LCM apart. That is a massive amount of complex math unpacked in just a few minutes.
But, finding the LCM isn't just an end in itself, it's a completely vital tool. So now that you've mastered these building blocks, what other complex math problems will this powerful tool help you unlock next?
Thanks for watching. Bye, students. Don't forget to subscribe for more math fun videos. See you in the next lesson.